Welcome. So in this video, we're going to go through using logarithms to solve exponential equations and inequalities. Let's begin with the first question before us, which is 2 raised to the x equals 5. So what we need to do here is solve for x, and as the title says, we'll be using logarithms to do so. So how can we use our knowledge of logarithms to solve this? Well, we can rewrite it with that knowledge. We know that my exponent is going to be my answer. Then we know it's going to be log. My base is going to be 2. And this is going to be my argument. And just like that, we've answered the question. That was pretty easy, wasn't it? We just answered it. That's what your answer is going to be. That's what x is equal to. Now, before we move on, sometimes in a test or in an exam, they might ask you to give your answer to 2 decimal places, which means you're going to need the approximate. So not the exact, but the approximate value. In order to get that, you're obviously going to have to use your CAS. So how do you use your CAS to get something in terms of decimals? So what we're going to do is we're going to say, all right, I have control log of 2 to the 5. Now, if you hit enter, it's just going to give you the exact value. But we don't want the exact value. We want the approximate. As you can see, above the enter sign is those squiggly equal signs, which is going to give you the approximate value. So what we're going to do is we're going to rewrite what we have. So by just highlighting it and pressing enter, it brings it back down. Handy hint for the CAS. Now, if we want to find the approximate, we're going to hit control, then hit enter. And as you can see, we now have 2.32. So if the question did ask us to give it in terms of 2 decimal places, we could say it's 2.32. And now we're going to highlight that. Just like that, we've answered our first question. But before we go on, I want to show you another way of answering this. So I'm putting an or to show you this is just another way of approaching it. So I'm going to rewrite our question, which is 2 raised to the x equals 5. That's an ugly x. Now, another way we could answer this question is by saying, all right, I'm going to take log of 10 of both sides. I'm then going to scroll down and I'm going to do that. I'm going to go log of 10 of 2 to the x is going to be equal to log of 10 of 5. So I just took log of 10 of both sides. Now remember, I'm trying to solve it for x. So I want to get that x by itself. One step towards that is to bring my x to the front here. So that's my third log law, bringing my x there. 10 to the 2 equals log of 10 to the 5. Next, remembering I want to get that x by itself, I'm going to divide both sides by log 10 to the 2. So that's going to leave me with x equals log of 10 to the 5 over log of 10 to the 2. And just like that, we have another way of representing our exact value. So if we come up here, log 2 to the 5, that's the same thing as this. Now, this is utilizing a rule that I said we'll get to later, and let me talk about that rule now. So if we just go here for a second, if we have, so this is just a little rule that's really good to know. If you have log 2 to the 5, another way you can write that is log. Now the base doesn't matter here because we'll be dividing, but let's just say base to the 10. But it could be base to the e, could be base to whatever you want, it doesn't matter. Then my argument can go here, then over log 10. So this is where you just have to make sure your bases are the same. It can be whatever base you want, they just need to be the same. And then you put in 2 there. These right here are the same. And what you've seen is, look, we got the same here, log 5 to the 2. So if I was to just zoom out so you can get a big picture of this, we have just done that. So this just proves a law about when you're changing the bases. If you go back to the certain page in your booklet, if I can tell you what that page is, give me a second. It is page 6 in your booklet. You're going to see this as one of the laws of logarithms. Your textbook doesn't touch on it that much, so that's why we're not going into too much detail about it, but now you've seen it, so that's really good. So that just proves what we're doing. And another place where you could see this is if you came to your CAS and you went menu, you went algebra, you went solve, and you said, well, I'm trying to solve this for x. So you go 2 raised to the x, whoops, sorry, I just forget, 2 raised to the x equals 5, and you're trying to solve it for x, close brackets, enter, look, you get log of 5 over log of 2, which is what we got right here. Now it has ln, which means the natural log. So that is meaning that instead of having a log of 10, they're having a log of e. But again, as I said, it doesn't matter. As long as you're using the same base for both your numerator and denominator, is not going to matter because you are dividing. So that is showing you that change of log base rule and showing you different ways of answering a question like this. Hopefully all that made sense. The real takeaway message, the crucial bit of information is right here, but I thought it was important just to give you a bit of background into what we're doing. So hopefully that made sense for that. Let's now zoom in and go into our next question. And this is, we're going to do it far more simply. Just do it the first way I showed you. How would you answer this? So we're solving for x using our log knowledge. So that means that my x is going to be my answer. Then it's going to be log of a base of 3 raised to 12. So that's going to be your exact answer right there. If you wanted to give your answer to some decimal places, what you would have to do is use your CAS, go control log 3 to 12. Whoops, that didn't work. To 12, and then hit enter. Whoops, sorry, I got too excited and I hit enter. You're going to have to hit control, enter, 2.26. 2.26. That is going to be your approximate. I'm not going to go into the other method here. Hopefully that made sense. Let's keep on moving on. Let's go down to this one. To answer this, we're going to be using the exact same logic. So this right here, my exponent, is going to be my answer. Then it's going to be equal to log of my base, which is 5. My argument will be 7. I now am going to rearrange this to get x as my answer. So to get x by itself. So that means it's going to be x. So let me go 2x. Let me plus 1 to both sides to get rid of this minus 1 here. Log 5, 7 plus 1. Then I'm going to divide by 2. X equals log 5, 7 plus 1 over 2. And there is your exact answer, just like that. If you wanted to find the approximate, what you're going to do is come to your CAS, go control, let me put the division sign first, control log 5, 7 plus 1 over 2 is going to equal, I did it again, I didn't hit control, control, enter, 1.10, 1.10. And there is your approximate value of it. Let's go on to the next one. Again, exactly the same logic here. So what we're going to be doing is saying this is going to be, whoops, your exponent is your answer. So 1 minus x is equal to log of 0.3 is your base. Then 12 is your argument. Now you want to get x by itself, so I'm going to subtract 1 from both sides to get negative x is equal to log of 0.312 minus 1. Now I want to get rid of this negative, so I'm going to divide both sides by negative 1, which is going to give me x is equal to negative log of 0.312 plus 1. That is going to be your exact solution. So we plus 1, then we subtracted 1, then we divided by negative 1 to get that. If you wanted to get the approximate solution, you're going to have to use your CAS, and what you're going to do is go, I have negative, control log 0.312 12 plus 1. Enter, 3.06, 3.06. That is your approximate. Perfect. Hopefully all that made sense. We're now going to move on to something a little bit different, and that is learning about inequalities.